Now that we have simplifying rational expressions under our belt, we're going to look at how we multiply rational expressions. In this first situation when we're multiplying rational expressions, we're looking at for multiplying monomials in the numerator and denominator. When you multiply rational expressions, remember, keep in mind, you multiply the numerators together, you multiply the denominators together. So multiply across the numerator and denominator first, then identify common factors and reduce. When you're dealing with monomials in the numerator and denominator, this identify common factors and reduce means you will be applying your properties of exponents. The power rule, the product rule, and the quotient rule. So if I'm looking at this example, I have 2a squared over 5b squared c times 3bc squared over 8a cubed. What I'm going to do is I'm going to multiply across the top 2a squared times 3bc squared. 2 times 3 is 6. And then put your variables in alphabetical order. A squared, b, c squared. 5 times 8 is 40. Put the variables in alphabetical order. A cubed, b squared, and then c. Now that you have one term, we can simplify. Simplify the coefficients like they're a fraction. 6 over 40 is going to become 3 over 20. You have a squared over a cubed, so you have 2 a's in top, 3 a's in the bottom, so these two can cancel out, and you're left with 1a in the bottom. You have b over b squared, so 1b in the top, 2b's in the bottom, so that means you're going to be left with 1b in the bottom, so a b. And then c squared over c, 2c's in the top, 1c in the bottom, so this c cancels, and you're left with just a c in the top. And so my final answer, simplified rational expression, is 3c over 20 ab when I multiply the two rational expressions together. So this is situation number one, if you have monomials in the numerator and denominator. Now the second situation you may have going on is if you have polynomials in the numerator and denominator. What you do is factor each numerator and denominator completely first. You need to keep in mind this could be GCFs. Then multiply across the numerator and denominator and cross out any common factors from there. So if I have this example, 3x plus 6 over 7x minus 7 times 14x minus 14 over 5x plus 10, what I'm going to do first is I am going to factor each numerator, each denominator. So 3x plus 6, that has a GCF of 3. So I'm left with 3 times x plus 2. Now I'm going to go down to the denominator, 7x minus 7. There's a GCF of 7. You factor it out, you're left with x minus 1. Go up to the other numerator, 14x minus 14. They have a GCF of 14. You're left with x minus 1. You have 5x plus 10. It has a GCF of 5. You're left with x plus 2. Now the second step says multiply across the numerator and the denominator. Now I don't show that because if I multiply across the numerators, I'm just going to put them next to each other. It's like extending this fraction bar. If I see all multiplication going on, then what I can do is just go right to crossing out any common factors. It has an x plus 2 here and here. It has an x minus 1 down here and up here. And so I'm left with 3 times 14 on the top, which is going to be 42. I'm left with 7 times 5 on the bottom, which is 35. So how can I simplify 42 over 35? Well, 7 goes into 42 6 times. 7 goes into 35 5 times. And so the actual simplified rational expression after we multiplied these two rational expressions together is 6/5. Now see, that is the fun part of math, is this multiplication of two rational expressions. This complicated problem is actually a funny way of writing the number 6/5. So it's the same process we've been doing when we've been simplifying. It's just right now you have to remember when you multiply, Make sure you factor first and cross out any common terms after you multiply across the numerator and denominator.